guys, and welcome to this session on DevOps for beginners, where we will break down one of the most in-demand career paths in tech today. In today's fast-paced software world, companies are constantly looking for ways to deliver features faster with higher quality and fewer bugs. That's exactly where DevOps comes in. DevOps is not just a buzzword. It's a cultural and technical shift that brings development and operation teams together. It's about breaking down silos, automating processes, and ensuring faster, reliable software delivery through continuous integration and continuous deployment. Whether you're a developer, a system administrator, or someone looking to switch into tech, this session is designed to give you a solid foundation in DevOps, show you the most important tools, and even walk you through building your own CI/CD pipelines. And here's what we will cover step by step. First, we will understand the core concepts and why DevOps is transforming software development. And then, get familiar with the stages of DevOps from planning and development to monitoring and feedback. Followed by, we will explore popular tools like Git, Docker, Kubernetes, Jenkins, Ansible, and more, and how they support each stage of the DevOps lifecycle. And then, we will learn what CI/CD really means and see how it enables automation and faster delivery. Followed by, we will go hands-on with Jenkins, one of the most widely used tools to set up a working CI/CD pipeline. And finally, we will guide you on how to build your DevOps skill set, what roles to aim for, and how to kickstart your career. But before we begin, please like, share, and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, check out Edureka's DevOps training program. Offers comprehensive hands-on learning of key DevOps tools like Git, Jenkins, Docker, Ansible, Terraform, Kubernetes, Prometheus, and Grafana. It is designed to make you a certified DevOps practitioner. The course focuses on real-world applications of continuous development, configuration management, continuous integration, and continuous monitoring throughout the software development lifecycle. And with live instructor-led sessions and practical projects, you will gain the skills to excel in real-world DevOps environments. So check out the course link given in the description box below. Now, let's get started with our first topic, that is, what is DevOps?
What is DevOps? DevOps is basically a combination of two words, development and operations. So what do we get when we combine these two? Simply speaking, DevOps is a culture that implements technology in order to promote collaboration between development and operations team to deploy code to production faster in an automated and repeatable way. The goal of DevOps is to increase an organization's speed when it comes to delivering applications and services. Many companies have successfully implemented DevOps to enhance their user experience. Let's take for example, Facebook's mobile app, which is updated every 2 weeks, effectively telling users, you can have what you want and you can have it now. Ever wondered how Facebook is able to do this so smoothly? It's the DevOps philosophy that helps Facebook ensure that its apps aren't outdated and that its users get the best experience. Facebook accomplishes this through a code ownership model that makes its developers responsible. That includes testing and supporting through production and delivery for each kernel of code they write and update. It's through policies like this that Facebook has developed a DevOps culture and has successfully accelerated its development lifecycle. Industries have started to gear up for the digital transformation by shifting their needs to weeks and months instead of years while maintaining high quality. As a result, we will soon see that DevOps engineers have more access and control of the end user than any other person in the enterprise. So what are you waiting for? Don't be in the sidelines when that happens. To master your skills, enroll in Edureka's DevOps certification program and become a leader. Until next time, happy learning!
Why DevOps? So before DevOps, we had this waterfall model of software development. This model was a straightforward and a linear model that followed a top-down approach. As you can see in this diagram, it had various phases, starting with requirement gathering and analysis. In this phase, you gather the requirements from the client for developing an application, and then you analyze those requirements. Once you're clear with the requirements, you proceed further with the design phase. In this phase, you think about how the software is going to look like. and you prepare a blueprint of the software. The next phase is the implementation phase, where you begin the coding of the application. Once the application is developed, it is tested in the verification phase. After testing, the application is deployed on the production servers. And once the application goes live, it is monitored in the maintenance phase. So it looks like a perfect model, guys, isn't it? But no, this wasn't a perfect model since it had a few drawbacks. One of the drawbacks of this model is unless you complete a particular stage, you cannot proceed to the next stage. This was a very time-consuming model. This model was suitable only for projects where requirements are stable. By stable, I mean the requirements will not change with the time. But in today's world, this is a very unlikely scenario because requirements keep on changing. No working software is delivered until the final stage of the waterfall model. Also, this model was not suitable for large projects and the object-oriented projects. So these were a few drawbacks of the waterfall model. The next model is the agile model. In this model, the software is broken down into various iterations. Each iteration has various phases such as planning, design, development, and so on. The duration of each iteration is generally 2 weeks to 8 weeks. So what happens in agile model is you release the software in the first iteration. After this, you gather the feedback from the end users or the customers about the application and you try to incorporate those changes into the second iteration. And then you again release the software into the market, which is the second iteration. You again repeat the same procedure and then you release the software again, which is the third iteration, and so on. So this model was better than the previous model. But this model too had a few drawbacks. While this model brought agility to the development team, the operations team still did not come up to speed with the development team. Because of this, there was constant conflict between the development team and the operations team. This conflict hampered the pace of the software development and the release. So this was the biggest drawback of the agile model. And the next model or the next approach is the DevOps approach. So guys, what is DevOps? The term DevOps is a combination of two words, namely development and operations. DevOps is a practice which allows a single team to manage the entire application development lifecycle, that is development, testing, deployment, and operations. DevOps is a software development approach through which superior quality software can be developed quickly and with more reliability. DevOps consists of various stages such as continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring. The aim of DevOps is to shorten the system's development lifecycle while delivering features, fixes, and updates frequently in close alignment with the business objectives. As you can see in this diagram, these are the various tools that are used in DevOps. And now let us have a look at the DevOps lifecycle. As you can see in this diagram, these are the various phases of the DevOps lifecycle. That is continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring. Now let us have a look at each of these phases one by one. The first phase of the DevOps lifecycle is continuous development. This is the phase which involves planning and coding of the software application's functionality. There are no tools for planning as such, but there are a number of tools for maintaining the code. The vision of the project is decided during the planning phase and then the actual coding of the application begins. The code can be written in any language, but it is maintained using the version control tools. These are the continuous development DevOps tools. The most popular tools used are Git, SVN, Mercurial, CVS, and Jira. Also, tools such as Ant, Maven, and Gradle can be used for building or packaging the code into an executable file so that it can be forwarded to the next phases. So guys, tools like Git enable communication between the development and the operations team. And this was one of the drawbacks of the previous model, that is the agile model. So now let us have a look at the version control tool called Git. Git is a distributed version control tool that supports distributed nonlinear workflows by providing data assurance for developing quality software. When you are developing a large project with a huge number of collaborators, it is very important to have communication between the collaborators while making changes in the project. So imagine a scenario, if you are a team of 10 developers and you're working on a project. So now what happens is, if a developer commits any change into the code and that change causes an error. So now how will you track down which developer made what change into the code and how to solve that error? So here tools such as Git solve the problems related to maintaining the code. What happens in Git is there is one central repository or the main server where the code of your application is present. And there is also one local repository where you can also have the code for your application. you can fetch the code from the main server to the local repository using pull, and using push, you can forward the code from the local repository onto the main repository or the main server. Also, this is the working directory or your workspace where you develop the application, and you can fetch the code from the local repository onto your working directory using update. Using commit, you can forward the code from your working directory to the local repository. So this is an overview about the Git. So now why do we use Git? Imagine for any reason this server or the main repository crashes or is unavailable. So in such a scenario, the local repository still has the code for your application. So this is an advantage of using tools such as Git. So this was all about continuous development. The next stage of the DevOps lifecycle is continuous integration. This is the stage where the code supporting new functionality is integrated with the existing code. Since there is continuous development of the software, the updated code needs to be integrated continuously as well as smoothly with the systems to reflect the changes to the end users. The changed code should also ensure that there are no errors during the runtime, which allows us to test the changes and check how it reacts with other changes. So there's one very popular tool that is used in this phase, which is known as Jenkins. Using Jenkins, one can pull the latest code revision from the Git repository and produce a build which can be finally deployed to the test servers or the production servers. So let me put this in simpler words, guys. Imagine if a developer commits any change onto the code which is available on the Git repository. As soon as there is change in this code on the Git repository, Jenkins will fetch that code and it will produce a build. This build is nothing but an executable file, which is in the form of a jar file or a war file. And this build can be forwarded to the next stages, that is either the production servers or the test servers. So this was all about continuous integration. The next phase of the DevOps lifecycle is continuous testing. This is the stage where the developed software is continuously tested for bugs. For continuous testing, automation testing tools such as Selenium, TestNG, JUnit, etc. are used. These tools allow the QAs to test the multiple code bases thoroughly in parallel to ensure that there are no flaws in the functionality. In this phase, you can make use of Docker containers for simulating test environment. Selenium does the automation testing and the reports are generated by TestNG. But to automate this entire testing phase, you need a trigger, and that trigger is provided by the continuous integration tool such as Jenkins. Automation testing saves a lot of time, effort, and labor for executing the test cases. Besides that, report generation is a big plus. The task of evaluating which test cases failed in the test suite gets simpler. These tests can also be scheduled for execution at predefined times. Once the code is tested, it is continuously integrated with the existing code. So this was all about continuous testing. The next phase of the DevOps lifecycle is continuous deployment. It is the stage where the code is deployed to the production environment. Here, we ensure that the code is correctly deployed on all the servers. Now, it is the time to understand why DevOps will be incomplete without configuration management tools and containerization tools. Both the set of tools help us in achieving continuous deployment. Configuration management is the act of establishing and maintaining consistency in an application's functional requirements and performance. So let me put this in simpler words. It is the act of releasing deployments to servers, scheduling updates on all the servers, and most importantly, keeping the configurations consistent across all the servers. Since the new code is deployed on a continuous basis, configuration management tools play an important role for executing tasks quickly and frequently. Some popular tools that are used in this stage are Puppet, Chef, SaltStack, and Ansible. Containerization tools also play an equally important role in the deployment stage. Docker and Vagrant are the popular tools which help produce consistency across the development, test, staging, and the production environments. Besides this, they also help in scaling up and scaling down of instances easily. It eliminates any chance of errors or failures in the production environment by packaging and replicating the same dependencies and packages used in the development, testing, and the staging environment. So this was all about the continuous deployment. The final phase of the DevOps lifecycle is continuous monitoring. This is a very crucial stage in the DevOps lifecycle, which is aimed at improving the quality of the software by monitoring its performance. This practice involves the participation of the operations team who will monitor the user activity for any bugs or improper behavior of the system. This can also be achieved by making use of dedicated monitoring tools which will continuously monitor the application performance and highlight the issues. Some popular tools used are Splunk, ELK Stack, Nagios, New Relic, and so on. These tools help you monitor the application and the servers closely to check the health of the system proactively. They can also improve the productivity and increase the reliability of the system, reducing IT support costs. Any major issues found could be reported to the development team so that it can be fixed in the continuous development phase. These DevOps stages are carried out on loop continuously until the desired product quality is achieved. So guys, this was all about DevOps lifecycle.
Have you all ever imagined why DevOps tools are important? DevOps tools are essential for streamlining and enhancing the software development lifecycle. They enable teams to automate repetitive tasks, improve collaboration, and deliver software more reliably and efficiently. Here are some key reasons why DevOps tools are important. First is its automation and efficiency. Tools like Jenkins, Ansible, and Docker automate tasks such as testing, deployment, and configuration management. They reduces manual work, minimizes errors, and speeds up processes, enabling faster releases. Next is its collaboration and communication. Version control tools like Git and GitLab facilitate collaboration by allowing multiple developers to work on code simultaneously. DevOps tools also bridge gaps between development and operation teams, promoting shared responsibility and transparency. Consistency and reliability. Configuration management tools like Puppet and Chef helps enforce consistent environments, reducing "it works on my machine" issues. Infrastructure as code tools like Terraform enable the reproducibility of environments, ensuring reliable deployments. Next we have is the scalability and flexibility. Tools like Kubernetes and cloud management platforms like Terraform for multi-cloud make it easier to scale applications up or down, manage resources, and support dynamic business needs. Last is its continuous improvement. Monitoring tools like Prometheus and visualization platforms like Grafana provide real-time insights into system performance. This feedback helps teams identify issues early and optimize continuously for improved performance and user satisfaction. Moving on to a first concept, that is version control. Version control in DevOps refers to practice of tracking and managing changes to software code, configurations, and document over time. It enables teams to collaborate on projects, ensuring that multiple developers can work on the same code base without conflicts. Version control systems like Git allow you to track changes where every modification is saved as a version, so you can go back to any previous state. Next is its collaborative efficiency, where multiple team members can work on different features or bug fixes simultaneously. Ensure code integrity, where changes are reviewed, merged, and tested before they are deployed, maintaining a stable code base. Last comes its rollback. In case of errors or bugs, you can easily revert to a previous working version of the code. In DevOps, version control is a foundational practice for continuous integration and continuous delivery, that is CI/CD, enabling faster development cycles and safer deployments. The tools involved in this first is the Git. Git is a version control system that tracks changes in source code. It allows multiple developers to work on projects simultaneously. Supporting branching and merging strategies, Git is a distributed version control where every developer has a full copy of the project's history, enabling offline work and more robust collaboration. Branching and merging. Git allows you to create separate branches for new features or bug fixes, which can be worked on independently and then merged back into the main code base. Git also has the commit history, where each change can be saved as a commit with a unique ID, making it easy to review, track, and revert changes. Git has its collaboration, where Git supports collaboration among teams by allowing multiple developers to work on different parts of the code simultaneously without conflicts. Now let's see how Git's dashboard looks like. Git is a foundational in DevOps pipeline for continuous integration, continuous delivery, making it easier to manage code across teams and automate deployment processes. Popular platforms like GitHub, GitLab, and Bitbucket use Git for project hosting and collaboration. Now let me show you how the Git's dashboard looks like. So open the web browser, type Git on the search bar, click on the first link that you can see here on the screen. There you go. This homepage shows the Git's dashboard. It is a free, open source and high performance version control system that's easy to learn and support advanced features like branching and staging. It offers links for documentation, downloads and also community engagement, along with details of the latest release. Now, onto the left hand side, you can see that there is About written. This links to information about the advantages of Git compared to other version control systems. Now let's see what is in the About. Under About, you can see branching and merging, where it focuses on Git's branching models. Then comes Small and Fast, likely discusses about Git's lightweight and efficient performance. Then we have is the Distributed, covers Git's distributed nature as well. Then we also have Data Assurance, talking about data integrity in the Git. Staging area is again which explains Git's staging area for committing changes. So it will show you each and every step how staging area happens. Free and open source highlights Git's open source status. Then last we have is a trademark. It refers to Git's trademark information. Okay, so how the Git trademark policy happens and the guidelines and how things has to be prohibited using the marks and etc. Now under documentation, this provides all the access to detailed documentation including command reference, tutorials and other resources as well. By clicking download, which offers download links to Git clients for various platforms. For example, let it be Windows, it can have Mac OS and even Linux etc. as well. It will show you the latest source release of it. Last here we have is the community. Links to Git community including mailing list, forums and development resources. So this is how the Git dashboard looks like. Now let me show you how the Git command works. So for that, type git bash. I have installed git bash from my Microsoft store. Okay, so this is how the git bash looks like. So let's type the command first. I'll be typing a simple command to check the version of the Git which I have installed. For that, I have typed git --version. Here you go. You can see the Git version, that is 2.45.2.Windows 1. Okay. Now, let me also show you how to initialize empty Git repository. Before that, let me show you how you can take a help of any command in case you forget. Okay. So git --help command will help you to reach to any command in case you forget or you want to just see what the description of the command looks like. So for example, if it is add, you want to add any kind of files, or if you want to add any repository to your file, anything or any content, you can know what kind of changes and what kind of description for this can be. You have add, move, you also have restore and remove as well. Okay, so all these will help you to fetch and know what kind of commands can be used and where. Now with that, let's continue to initialize the empty Git repository. For that, let's create a directory by typing mk directory. So I will just create anything called opt, name of it. So let's change the directory to opt now. Yeah, here you can see that my directory is changed. Now let's check if there's any files in the opt. You can see there's no files. Okay, now let's initialize the Git by typing git init. There you go. You can see initialized empty Git repository in the opt directory. Okay, now let's see what are the untouched files that we have. So ls-a will show you all the files that should be untouched. Okay, so remember .git shows that all the repositories that is considering in this should not be untouched because it has this configuration, and do not touch the .git. If you touch, the initialization will go off. Okay, now let's remove the .git, or let's lose the .git from my opt repository. So for that, let me type rm-rf.git. Now let's type ls-a and check for the file that should be untouched. Here you go. You can see .git has been lost and even we have been removed it as well. So this is how git command works. So you can also try out several commands in git bash as well, like this. Then we have is the GitLab. GitLab provides a version control alongside integrated CI/CD capabilities, facilitating collaboration through issue tracking, merge requests, and also project management features. Version control serves as a foundation for CI/CD by enabling teams to manage code changes and maintain a history of modifications. Code changes pushed to Git or GitLab trigger subsequent stages in the CI/CD process. Git is a web-based DevOps platform that provides a complete toolchain for software development, from version control to CI/CD. It helps teams collaborate on code, automate builds, test integrations, and deploy applications efficiently, all in one platform. With features like Git repositories, issue tracking, and pipeline automation, GitLab streamlines the development and deployment processes for faster, more secure, and software delivery. The video that is provided showcases the GitLab Enterprise homepage. This platform is designed to provide a comprehensive solution for software development and collaboration. Let me also show you how GitLab's dashboard looks like. For that, let's type GitLab, then click on the first link that you can see on the screen. Here you go. This is the home screen of the GitLab. So, here from the left-hand side, we have Platform, which is likely refers to the core GitLab platform, which offers features like version control, issue tracking, CI/CD pipelines, and more. When seeing on Solutions, this section probably links to specific solutions or offering within the GitLab platform, such as security, DevOps, and AI. Coming to pricing, this likely leads to information about the different pricing plans and tiers for GitLab. Resources. This section might contain documentation, tutorials, and community resources for the reference. Then you can see here you have Company. This could link to information about the company, its mission, and its team as well. You can also see we have Get Free Trial, a call to action to sign up for a free trial of GitLab. Here you can see Sign In button, a button for existing users to log into their GitLab account as well. So you can just type your username and password, or if you're not signed in, you can even create one as well. Overall, the homepage aims to convey GitLab's comprehensive approach to software development and its commitment to leveraging AI to enhance the development process. It highlights the platform's capabilities, encourages users to sign up for a free trial, and provides resources for further exploration as well. As we have seen, tools like Git and GitLab, which is a web-based DevOps platform that provides a complete toolchain for software development. Now let's see what CI/CD is. CI/CD is a continuous integration and continuous delivery. It is a DevOps practice that automates the software development lifecycle. Continuous integration, where developers frequently integrate code with a shared repository, where automated tests run to ensure code quality and detect issues early. Continuous delivery, which automates the process of preparing code changes for production, ensuring that updates can be deployed quickly and reliably. Together, CI/CD speeds up development, improves collaboration, and reduces the risk of errors during deployment. The tools included in CI/CD first is Jenkins, an open source automation server that supports building, testing, and deploying applications through pipelines. It integrates with various tools and plugins to create robust CI/CD workflows. Jenkins has continuous integration, where it automates code integration by triggering builds and tests upon commits, helping catch issues early and improve code quality. Then it is also having the continuous delivery, where Jenkins automates deployment after successful builds, ensuring consistent delivery to staging or production environments. Extensive plugin ecosystem. With over 1,800 plugins, Jenkins integrates with many tools, that is Git, Docker, Slack, to support diverse DevOps workflows. Pipeline as code. Jenkins allows CI/CD pipelines to be defined in code, that is Jenkins file, making workflows repeatable and version controllable. Declarative and scripted pipelines. Offers two types, that is declarative pipelines for simplicity and scripted pipelines for complex Groovy-based workflows. Then it's distributed builds. Jenkins can distribute tasks across multiple nodes, enabling parallel job execution for faster builds in larger projects. Extensive community support. Jenkins has a large community with comprehensive documentation and plugins, making it easy for teams to adopt and customize. Cross-platform and open source. Jenkins works on multiple OSs and is open source, offering flexibility and customization for diverse project needs. Monitoring and notification. Jenkins notifies teams through email, Slack, etc. on build and deployment statuses to keep everyone informed. Last is its DevOps pipeline essential. Jenkins' flexibility and scalability make it a key DevOps tool, streamlining testing, integration, and deployment. The Jenkins dashboard offers a comprehensive view of CI/CD processes, allowing teams to manage and monitor automated workflows for building, testing and deploying applications. It provides an overview of all active projects and pipelines, showing the status of each built job, like success, failure, or in progress. Users can view recent builds and access detailed logs for debugging as well. Now let's see how the Jenkins dashboard looks like as well. For that, let's type Jenkins in the search bar of the web browser. You can see the first link that is named Jenkins. Click on it. Here you can see the Jenkins dashboard. The navigation bar at the top provides the link to various resources, including the documentation, community, and also the security. Now, here you can see the two buttons, that is download and documentation. Let's click on download and see. So under download, we have download and deploy. This section emphasizes the two primary release lines of the Jenkins, that is long-term support, that is LTS, and weekly releases, which provides links to learn more about each of their respective advantages. Here you can see stable. This section highlights the stability and security focuses of LTS releases. It mentions the frequency of updates and the inclusion of bug fixes and security patches. Weekly releases. This section emphasizes the rapid delivery of new features and bug fixes in weekly releases. It's ideal for users who want the latest release and also is willing to accept potential instability. Here, when you're scrolling down, you can see downloading Jenkins. This section provides instructions on how to download Jenkins in various formats like WAR files, native packages, installers, and Docker images. It also provides a link to hardware and software requirements for running Jenkins. Overall, this page provides clear information about Jenkins release lines. We also have a download options and installation steps. It caters to different user needs, so whether you prefer stability or the latest release. Now when you click on documentation, under documentation, we have installing Jenkins, platform information, how to use Jenkins, pipelines, and etc. So you can refer to this to know more information about Jenkins as well. This is how the overall dashboard of Jenkins look like. The next we have is GitLab CI/CD. Integrated with GitLab, it uses GitLab ci.yml files to define CI/CD pipelines, automating the testing and deployment process as soon as the code changes are detected. GitLab CI/CD is highly flexible and it supports scaling workflows, making it ideal for continuous software delivery in DevOps. Once the code is committed to version control, CI/CD tools like Jenkins or GitLab CI/CD automatically trigger builds and tests. Successful build create deployment artifacts. That is how it moves seamlessly to the next stage of the containerization. With that said, now let's see what is containerization. Containerization is a method in DevOps where applications and their dependencies are packed together in isolated environments called containers. Containers include everything needed to run an application, such as libraries, dependencies, and configuration files. They are lightweight and can run consistently across different environments, from development to production. This enables DevOps teams to build, test, and deploy applications efficiently, as containers ensure that the application will behave the same way regardlessly of where it's run. Its consistency across different environments is also great. Isolation of application avoiding conflicts. Efficiency with faster startup times as well. The first tool that is involved in containerization is Docker. A Docker is a platform for creating, deploying, and managing lightweight, portable containers that package applications and their dependencies, ensuring consistency across different environments. Here is why Docker is valuable. First is its consistency across environments. Docker ensures the app runs the same way, whether on a developer's laptop, in a test environment, or in production, reducing "it works on my machine" issues. Portability. Docker containers can run on any platform that supports Docker, making it easy to move apps across different systems. Then we have is its scalability. Docker makes it easy to replicate containers, enabling horizontal scaling to handle more load without complex configuration. Isolation. Each container runs independently, which isolates application and reduces conflicts between dependencies. Last is its efficient resource usage. Docker containers are lightweight and efficient, using less memory than traditional virtual machines, which helps optimize server resources. Docker actually streamlines application deployment, reduces infrastructure costs, and also support agile development and continuous delivery workflows. The Docker dashboard provides a visual interface to manage containers, images, volumes, and networks within Docker. It displays an overview of active and inactive containers, allowing users to start, stop, restart and delete them easily. The dashboard also lists available images which can be pulled from Docker Hub or created locally with details on size and version. Users can manage volumes and networks, critical components for container data storage and communication. For developers, it offers insights into resource usage like CPU memory per container, helping monitor performance and troubleshoot issues in containerized applications. Now let's see in detail how the Docker dashboard looks like. Go to your web browser. On the search bar, just type Docker. Click on the first link that is seen. This is how the homepage of the Docker website looks like. We have the Docker logo, which is iconic Docker logo representing a whale, as you know. Then in the navigation bar, which links to various sections of the website, includes products, developers, pricing, support, blog, and company. We also have a search bar to search any content on the Docker as well. We have a sign-in button and get started button. These allow users to log into the Docker accounts to start their Docker journey. As you can see, the headline given is develop faster and run anywhere. This actually emphasizes Docker's core valuable proposition, which enabling developers to build and run applications consistently across different environments. We have download Docker desktop button, which encourages users to download Docker, the primary tool for local Docker development. You can download on any OS system like Mac, Windows or Linux, and different versions of it is also given. Learn more about Docker, which is a link to more detailed information about Docker and its features. It gives you step-by-step information and also the documentation of how Docker is processed. We can just click on sign in. Just by adding your email and the password, you can sign into your Docker website as well. So it will just show you a message like welcome to Docker Home with your preferable name. Overall, the Docker homepage is designed to be simple, informative and inviting. It clearly communicates Docker's value proposition and provides easy access to key resources for the developers. Now, let me show you a small demo how Docker works. I'm writing the commands on Ubuntu on my VMware workstation. So, let me type the first command, that is to check the Docker version. So, after installation of Docker, I have checked the Docker version, that is 24.0.5. Now, let me show you how to pull a simple image from the Docker Hub. I've typed sudo docker run hello world. Hello world will be my image here. So let's see if the message has come. Yes, here you go. You can see hello from Docker. This message shows that your installation appears is working correctly. Okay. If you're having any doubts on how to just refer your commands or if you've forgotten to any commands, you can just open your web browser and type Docker installation on Ubuntu. Just click on the first link that you can see here. Here you can see install Docker engine on Ubuntu. Here you'll be getting all the prerequisites and also all the installation methods, how to install using the apt repository. Everything will be given in this. So you can go through this or you can refer this to write your commands as well. The next tool we have is Kubernetes, an orchestration tool that manages containerized applications, automating deployment, scaling, and load balancing across clusters. Kubernetes is an open source platform designed to automate the deployment, scaling, and management of containerized applications. Here's what makes Kubernetes essential. First is the orchestration. Kubernetes automates the placement, monitoring, and management of containers across clusters, ensuring applications run reliably. Next is the scaling. It adjusts the number of container instances based on demand, handling load balancing automatically. Self-healing. Kubernetes restarts failed containers, replaces containers, and kills containers that don't respond to user-defined health checks. Then we have the rollouts and rollbacks. Kubernetes can manage updates to applications, allowing smooth rollouts and rollbacks with minimal downtime. Then is the service discovery and load balancing. It provides built-in load balancing and service discovery, simplifying networking and containerized applications. Last is the resource management. Kubernetes efficiently distributes and allocates resources, maximizing the hardware's utilization. The Kubernetes dashboard is a web-based interface for managing and monitoring Kubernetes clusters. It provides an overview of the cluster's resources, including namespaces, nodes, and workloads such as deployments, replica sets, and pods. Through the dashboard, users can easily view the status of applications, checks the error and also see resources usage metrics like CPU and memory. It also allows for simple management tasks like deploying containerized applications, scaling deployments, and performing basic troubleshooting. Additionally, the dashboard offers insights into configuration maps, secrets, and persistent storage, enabling users to manage configuration and storage within the cluster. After the CI/CD process generates deployable artifacts like Docker images, Docker packages these applications into containers. Kubernetes then manages these containers, orchestrating their deployment and scaling as needed. Next, we will see about the configuration management. Configuration management is a vital component of DevOps that ensures computer systems, servers, and software are maintained in a desired and consistent state. It involves tracking and controlling changes to software and hardware components, which helps prevent problems between environments. By automating the deployment and configuration of systems, configuration management reduces manual errors and accelerates processes. It also includes version control, allowing teams to track changes and roll back to previous configurations when necessary. This practice fosters consistency across development, testing, and production environments, ensuring that applications run smoothly regardlessly of the setting. Common tools used in configuration management include Ansible, Chef, Puppet, and SaltStack, each offering unique features for automating system management and enforcing configuration as code. Overall, effective configuration management streamlines infrastructure management, enhancing reliability and efficiency in software delivery. The tools included in the configuration management is, first we have is Ansible. Ansible is an automation tool that simplifies configuration management, application deployment, and orchestration through YAML-based playbooks. It's agentless and can manage multiple servers simultaneously. Ansible provides a visual interface for managing automation tasks, playbooks, and also inventory, enabling users to monitor playbook runs, organize hosts, and also manage roles securely. Tools like AWX and Ansible Tower support these dashboards, simplifying task management and fostering team collaboration. I will just show you how the Ansible website looks like. So just type Ansible. When you scroll down, just click on the first link that you can see Homepage Ansible Collaborative. This shows the homepage of the Ansible website. On the navigation bar, you can see links to documentation, Galaxy, forum, resources needed for your references, and also Ansible automation platform as well. So when you scroll down, you have a small brief of what Ansible is. Here there's a link to how Ansible works. So you have a detailed view of how Ansible works, its efficiency architecture, credentials of Ansible, and so on as well. So here under documentation, we have project documentation and Ansible automation platform. So when you click on project documentation, here there is an Ansible community documentation where it offers you how to install the Ansible package. You can also run your first command and how to start writing your Ansible playbooks. Everything for the user is also given here. Under developers, you can see how to set up your development environment, learn how Ansible works. You can also write custom modules and plugins as well. Overall, the homepage aims to introduce Ansible as a powerful automation tool. It encourages community engagement and knowledge sharing. It also provides easy access to documentation and the resources as well. Provides and promotes the use of Ansible through Ansible automation platform. I'll just show you a small command how Ansible can just be written. So for that, just type Ubuntu. This Ubuntu app can be installed from the Microsoft Store itself. So after creating all the needed credentials, I've also installed Ansible. You can also install Ansible from the documentation which I have shown. So let's just type Ansible -- version to check what version of Ansible I have. Here you go. You can see I have the Ansible core version of 2.16.11. And even the configuration file is also given, the configured module search path, Ansible Python module location, and where is it installed. I also have the collection location of the Ansible, executable location of my Ansible, Python version that is 3.10.12, and etc. as well. So this is how you can just type your commands of the Ansible in your Ubuntu. The next tool we have is Puppet. It is a DevOps configuration management tool that automates the setup and maintenance of servers, ensuring consistent infrastructure across environments. With a central control system, Puppet manages multi-servers, corrects configuration drift, and also works across various platforms, helping teams streamline complex setups and maintain reliable, scalable systems. The Puppet dashboard is a user interface that allows DevOps teams to manage, monitor, and visualize their infrastructure managed by Puppet. Through the dashboard, users can oversee node status, view configuration changes, apply updates, and also monitor compliance in real time. It provides a central place to manage configurations, track reports, review logs, and also ensure that infrastructure consistency across environments, making it easier to maintain and scale complex setups. Now let me show you in detail how Puppet dashboard looks like. So, going to our web browser, in the search bar, let's type Puppet. Just click on the first link that you can see. This will direct to your home page of the Puppet. So, the Perforce logo is actually indicating that Puppet is now part of the Perforce family. So, in the navigation bar, which provides the links to various sections of the website, including products, community, service and training, resources that is needed for the reference, and why Puppet is also used. It will give you an overview of why Puppet is used. And we also have a search bar that allows you to search the content of the Puppet. We also have blogs written on Puppet, downloads, security, support, and community as well. So, when you just click on downloads, the Download Puppet Enterprise is the main call of action. We're promoting users to download their enterprise version of Puppet. It also gives you the installation Puppet Enterprise, provides a brief overview of the installation process and links to detailed documentation. As you can see, it is given the step-by-step how to install Puppet as well. And we also have a new way to install Puppet Enterprise. It highlights a new feature, the Puppet Installation Manager, which simplifies installation process. You have a lot of options for the installation here. Overall, this homepage actually aims to introduce Puppet as a powerful configuration management tool, encourages users to download and try Puppet Enterprise, provides easy to access for documentation and resources, highlights the latest features and improvements in Puppet. The next tool we have is Chef. It is a configuration management tool known for its infrastructure automation capabilities. It uses code-driven recipes to define configuration and can manage servers across complex, scalable environments, ensuring consistency and efficiency. Chef has its automated configuration, where Chef applies desired configuration across all servers, ensuring consistency. And its scalability. It simplifies scaling environments by deploying identical setups across new servers. Speed and efficiency. Automation accelerates deployment and update times, improving operational efficiency. And last comes its change tracking. Chef integrates with version control, making infrastructure changes easily, trackable, and also reversible. Once the infrastructure is provisioned and applications are containerized, Ansible can be used to automate the configuration of those containers and their environments as well, ensuring consistency and reducing manual errors. Ansible simplifies the orchestration of complex setups with its YAML-based playbooks. Moving on to Infrastructure as a Code. Infrastructure as a Code is a DevOps practice that automates the management and provisioning of computing infrastructure through machine-readable configuration files. This approach enables consistent, repeatable, and scalable setups by allowing teams to define infrastructure using code stored in version control. The key benefits of IAC include minimizing human errors, enhancing productivity, and also accelerating deployment times across development, testing, and production environments. The tool that is included in the Infrastructure as a Code is Terraform. Terraform is an open source tool that allows users to define infrastructure using a declarative configuration language, enabling provisioning across multiple cloud providers. Terraform are visual tools that help manage and monitor infrastructure as a code. Deployments created with Terraform. They provide features such as state management, which shows the current status of resources, and also the ability to visualize planned changes before applying them. These dashboards enhance team collaboration by offering shared visibility into infrastructure changes and also integrate with version control systems to track updates. Additionally, they enable real-time monitoring of infrastructure components, facilitating quick issue resolution. Tools like Terraform Cloud and Terraform Enterprise offer these capabilities, improving overall efficiency in infrastructure management. Now let me show you in detail how Terraform website looks like. Let's type Terraform. And here you can see Terraform by HashiCorp. So let's click on that. In the navigation bar, which provides the link to various sections of the website, overview, registry, we have also use cases, how Terraform community has been published, and we have tutorials to it, we have documentations, how Terraform can be installed, overview of Terraform as well. And we have a community. The search bar here is given to get any content from the Terraform. We have a download Terraform button, which prompts users to download the Terraform CLI tool. So let's click on download option. Here you can see list to the supported operating systems like Mac OS, Windows, Linux, FreeBSD, OpenBSD, and etc. For each operating system, it offers two primary methods. One is the package manager and the binary download. Here it also talks about the release information, which provides information about the latest Terraform release, including the version number and the release notes. So when you click on tutorials, you can have all the reference tutorials of how Terraform can be implemented. So when you click on documents, you can see docs overview. They just give you the overview of the Terraform and how configuration languages works in Terraform, what is the Terraform CLI, and etc. Here you also have a sign in button which allows users to log into their HashiCorp accounts to create a new account as well. Overall, the homepage aims to introduce Terraform as a powerful tool for infrastructure management, highlight its key features and benefits, encourage users to download and start using Terraform. It also provides a link to resources for learning and support. This is how the overall dashboard of the Terraform looks like. Terraform provisions the required infrastructure of application and services. This infrastructure can be configured and managed using tools like Ansible, bridging the gap between the IAC and configuration management. Moving on to a last concept, that is monitoring and logging. Monitoring and logging are essential components of the robust DevOps strategy, enabling teams to maintain system health, troubleshoot issues, and optimize performance. Now let's see what is monitoring. Monitoring involves continuous observing the performance and health of application and infrastructure. This includes tracking metrics such as CPU usage, memory consumption, response time, and error rates. Effective monitoring helps teams to detect issues early, identify and respond to performance bottlenecks and outages before they impact users. Then is its improved reliability. Ensure systems are functioning optimally, enhancing overall user experience. Last is its optimized resources. Analyze performance trends to make informed decisions about scaling resources. Logging involves collecting and storing detailed records of events and activities within applications and infrastructure. This data is crucial for understanding system behavior and diagnosing issues. The key aspects of logging include audit trails, which maintain a history of changes and actions for compliance and troubleshooting. Next is its error tracking. Capture error messages and stack traces to facilitate debugging. Last is the data analysis. Use logs to analyze user behavior, application performance, and system anomalies. Tools that is included are, first we have is Prometheus, a monitoring and alerting toolkit that collects and stores metrics as time series data, allowing for real-time monitoring and alerting on application performance. This is a screenshot of the Prometheus website, which is an open source monitoring and alerting toolkit. A main banner highlights Prometheus as a leading solution for turning metrics into insights. We also have options like Get Started and Download as well. Now let me show you a detailed view how Prometheus looks like. So let's just click on Prometheus. Here you can see Prometheus monitoring system and time series database. Click on it. So this is the home page of the Prometheus. As seen in the navigation bar, we have links to docs, download, community, support and training, blog, and a search bar to type or search any of the content in the Prometheus. So let's click on docs and see. When you click on docs, we have the overview of the Prometheus, like what Prometheus is, features, what are metrics, components, and the architecture of Prometheus, and so on. So when you click on download, we have the options to download Prometheus on your system. It also gives you the versions and also how to download it as well. So then we have community, support and training, and also blogs written on Prometheus as well. So under blogs, we have the latest news of the Prometheus itself. So in the home page, we have here a dimensional data where it explains Prometheus uses data model based on metrics and key value pairs to capture time series data. Then it is a powerful query as well. Where Prometheus offers PromQL, it is a query language for extracting and analyzing data. So in great visualizations, it supports multiple visualization options that include an expression, browser, or Grafana integration. And in efficient storage, it talks about how Prometheus stores data in memory and local disks. Then we have simple operations. It will show how server runs independently, relying on local storage, which simplifies deployment and reliability. In precise alerting, it is an alert that's based on PromQL, with a focus of dimensional information and notification handling. We also have many client libraries and many integrations, where Prometheus supports libraries in over 10 languages, so it is easy to service for the instrumentation as well. Then, in many integration, we have integrations with various systems like Docker, HA proxy, StatsD, and JMX. So Prometheus is widely used in DevOps for monitoring application, infrastructure, and systems. The next tool we have is the Grafana, a visualization tool that creates interactive dashboards from various data sources, including Prometheus, to monitor application health and performance. This image is from the Grafana Labs website, showcasing Grafana as a powerful visualization and monitoring tool. It describes Grafana as a pane of glass for monitoring various data sources, including AWS, Zabbix, and more. Grafana allows users to visualize data in dashboards and monitor different metrics in real time. The Grafana Cloud free tier offers features like 10K Prometheus metrics, 50 GB logs, 50 GB traces, and 500 VU K6 testing, along with numerous plugins and pre-built solutions. Trusted by companies worldwide, Grafana aims to provide an accessible and also comprehensive monitoring solution. So after deploying applications and services, monitoring tools like Prometheus continuously collect metrics, which can then be visualized in Grafana. This feedback loops inform developers to perform issues, which may also lead to further code changes and trigger the CI/CD cycle again. Now let's see the conclusion of what we have learned. These tools in one stream of DevOps will make the software development lifecycle more efficient in organizations. Here the flow starts from the source control, followed by CI/CD and containerization, then goes to configuration management and IAC, finally to continuous monitoring and logging. This cycle brings innovation in collaboration and automation, also with rapid results in deploying high-quality software and allowing teams to work together more effectively and respond quickly to changes. So, mastering these skills will widely enhance your capabilities in the field of DevOps towards developing high-efficient and reliable software programs.
Now, the different DevOps stages, as I told you, is version controlling, where the developer maintains different versions of the code in source code management system like Git, GitHub, GitLab, Bitbucket, Mercurial, and so on. Continuous integration process involves compiling the code, validating the code, reviewing the code, unit testing it, and integrating it. Compiling is the process where you take the source code and convert it into machine understandable. Validating the code is a process where you check for the programming mistakes done by the developer. Unit testing is the process of executing the test cases which are passed and failed. And finally, integrating the code for system testing. This code is then delivered to the test environment or the performance test environment or the UAT environment. It is then moved on and deployed. If it's successfully delivered into the test environment and the staging environment and testing is successful, it is then moved to the continuous deployment stage, wherein the code tested application is moved to the production server for releases. Let us execute this process with the help of the pipeline. First stage in any continuous integration flow is version control. Now, what is version controlling? And then building, then unit testing, deploying. So let me directly show you the demonstration rather than talking about it. Let us take some code given to us by the developer friend. So there are version control tools where developers can write the code and push the code. I have a GitHub repository where I have some code which is given to me by a developer. right? This is a Java based code. For this particular code, okay, for this code we have the source code, we have the test cases given by the developer. I am going to, and as soon as the developer writes the code in his local machine, let's say here he has written some piece of code, he'll push all of his code into this server. This is an external server where anyone can push the code. Okay, so this on this repository, on this particular repository, the developers are maintaining all the versions of their. Okay, so version controlling is the process to maintain, manage the changes that a developer or a user is doing to the files, common files accessed among by the team members. This repository is accessible by every team member. That is version controlling. I'm going to use a tool called as GitHub for version control. GitHub is an open source tool where 90-95% of the code is available for everyone to use. After version controlling, the next step will be to build the code, friends. To build the code. So build the code, we are going to make use of Jenkins server, friends. Now to tell you that what is Jenkins? Jenkins is an open source tool, friends. It is available for free, right? And it is provided by an application, by an organization called as 𝐶loudBees. Jenkins is like a robo. Whatever you tell to Jenkins, it will do it for you. You ask Jenkins to do a task, it will create a job, it will create it. You ask Jenkins to create a file, it will create. Delete a file, it will delete. You just need to instruct Jenkins to do a task. You just need to instruct Jenkins to do a task. It will perform the task for you, friends. It will perform the task for you. Okay, automatically at the scheduled time or at the scheduled interval, or whenever you have this, whenever you have set the trigger, automatically Jenkins will perform the task for you. Jenkins also provides you whatever task is executed by Jenkins, it provides a very good console output which will help us to troubleshoot the issues. It also maintains the history of the jobs that have been run and when it was run. It also provides a one-click philosophy to automate your entire CI/CD pipeline. Jenkins can do a continuous integration and continuous deployment flow for you, friend. So let us use Jenkins as a tool for performing the build steps. Now, build is a process which involves compiling the code, unit testing the code, and packaging the code, friends. Packaging the code into an artifact, friends. The code that I have picked up, if I show you the details of the code, the developer has already told this code when built, when this code is built, it is going to be built into a WAR file. So a package which will be generated will be of type WAR file. So I'm going to now to do the build process, friends. We have a tool called as Maven and its commands are available that will help us to build the code. But executing the Maven commands is done manually. DevOps says whatever is your manual process, please automate it. So using Jenkins, we are going to automate the process of compiling the code. So let me quickly log into this server. So I've already installed Jenkins and I'm going to log in with my credentials. Okay. Jenkins provides you. So if you are opening Jenkins for the very first time, if you're opening Jenkins for the first time, you may not have any particular job, right? So here, if you go to the new item, Jenkins will allow you to create a job, friend. Job is nothing but a task that you want Jenkins to do. So here, my first task that I want Jenkins to do is compile the source code that is given by the developer. Now, where is the source code? The source code is available in this SRC folder, main folder. There are some files available here. These Java files can be used to, these are the source code available that I want to compile. It is my first step in build process. So let us write down one dot. So let's say I'll write 04 dot compile is the first job that I want to build. Jenkins provide you different templates to build your code. Whenever you want to do the process of building the code, you can use a template called as a freestyle project. It is one of the easiest way of creating your project in Jenkins. But if you prefer to go with the CI/CD pipeline, you can go with the pipeline code also, friends. So let me take the pipeline code and show you how to create the pipeline. It's very easy to work with the pipeline code also. Here you will be writing the scripted pipeline code. Writing scripted pipeline code in Jenkins is very easy, as it is the format is quite readable, easy to understand, and it does not require any coding skills for you to write the code, friend. Also, Jenkins provide a pipeline syntax, that is a snippet generator, which will automatically generate the pipeline code for you. So let us use the snippet generator to generate the code that will create our CI/CD pipeline. Okay. So what I'm going to do, I'm going to go back and I'm going to recreate the job with a new name. I'm going to delete this job. I'm going to delete this job and I'm going to create a new job, and I'm going to call this job as CI/CD pipeline. Okay, and I'm going to take the template as a pipeline template. Whenever you have multiple jobs to be executed one after the other, it is always better that you take the pipeline as a template. Let us press OK. Now what I'm planning to build today, let me quickly explain you that also. So I'm going to build a following pipeline. Okay, just a moment, please. I'm looking for a PPT for a slide. Okay, so I'm going to build the following pipeline for you, as we were just seeing in the slide also, but this is more descriptive. First, we have the source code and Git, and I'm going to create a stage called as compile. Now, in this pipeline, first we are going to take the code from Git and we are going to compile the code. Okay, all right. So here we go. We are going to write the code here. Every pipeline code starts with pipeline. Okay. And here we are then going to start building the code on a particular, where do we want to run the code? So we want to run the code on an agent. Okay, agent N. And we also have an option called as tools. Which two tools I want to use to build my code from? The tools that I want to use is JDK, that is Java, because my code is Java based code. I want to use JDK, and this is the name of the tool, my Java. MVN is another tool that I want to, Maven is another tool that I want to use because we are going to build the code. For building the build automation tool that I am using is MVN Fridge. Okay, so here you go. The name of the tool that I have set up in Jenkins is my Maven. So this is the first phase in my pipeline where I'm creating set of tools. Okay, these are the two tools that I'm going to use to execute my task. Okay, then we are going to create something called as stages. Stages is here represent the steps that you want to perform. Okay, the task that you want Jenkins to perform. My first stage is going to be clone the repository, clone the code. Whatever is the code written by the developer, I want to clone. In this stage, you will write down the steps. What are the steps involved in it? So the steps involved is we have to just run a command. You have to tell Git, hey Git, clone the repository. By cloning the repository means whenever you create a Jenkins job, in its workspace, we want to get the code given to us by the developer. So this is the code given by the developer. Let us go and take the path of the repository here. This is the path of the repository available. I am going to use the snippet generator. In the snippet generator, if you see, there is a step section. I'm going to use a step called as get. In this step, it is asking us, give the repository URL which you want to clone. And then, just a second, friends. Let me quickly connect again. Let me give the name of the tool as Git and let me provide the GitHub repository. Give the name of the branch. Now this is a snippet generating pipeline syntax generator that will automatically generate the code for us for the particular stage. Git is a plugin that is available by default in Jenkins that can clone the repository. By cloning, we mean we are fetching the code from GitHub. Since we are building the CI/CD pipeline, I am assuming that you have an idea on what Git is, what GitHub is, and the Git commands like git clone, friends. After this is my first stage. This is my first stage, and if I execute this stage, let me save this stage. Now let me call this stage as a version control stage. Let me save it. So you will save the pipeline and you will build it fresh. So as I build a part of that particular, because there is only one stage, it is just going to clone that repository into Jenkins. Observe here, it has failed miserably. Let us see what is the issue. My Java, it says that no such property my Java. Okay, let me go and check it. Let us go to manage Jenkins. We have to actually go to global tool configurations and set up the Java path. So there is my Java here. It is available. Okay. Let me check the job again. Go to the configure section. Okay, the reason why it has failed is we have to provide the name of the tool in single quotes. Now if I will run the job again, let's build it again. So please see here on this particular, in the middle section of the job, it shows stage view. So whatever stage has been executed, it shows whether it is successful or failure, right? So I think the second build is successful here. Go here and check it. It has created every job that you create through Jenkins creates a workspace. Workspace is like an output directory where your code can be available. So if you go scroll down further, see cloning the GitHub repository. Now Jenkins has got hold of your code. You make any changes to your code, Git can use this pipeline to fetch the code. So that's continuous version controlling, friends. Now let me go ahead and create the next stage. The next stage is, so as part of my slide, I have completed this step of fetching the source code. Next step is to compile the code. So let me go ahead and create one more stage. And I'm going to call that stage as compile stage. Okay. Now in the compile stage, I am going to use steps and I'm going to use Maven to compile the code, friends. Maven is a build automation tool which provides us plugins which when run can compile your code. Compilation is a process where your source code which is available in your workspace is picked up and is converted into a machine understandable code. That is the class files or binaries or zeros and ones. So the command is mvn compile. This is the Maven command to compile the source code. Okay, and you are going to use shell. My server is an EC2 Linux based machine, a Red Hat Linux machine, so I'm using shell command to execute the Maven compile command. Okay, that's all. So let me save it and let me build it. I will show you the compiled files after this stage. So my third build, observe here, I'm slowly building my pipeline, version controlling and compiling the code. Okay, compiling the code. Now, if you go to your build here, no, let me go and show you in the workspace. If you see the workspace here, you can see at the following location in the target folder, my compiled files are available. That is the files that we have just converted just now. We have converted these files, compiled the Java files into class files. That's my first step in build process, friend. Now let me continue further writing my code. The next stage is going to be the stage called as unit test stage. You can also add a stage, a small security stage if you want to implement a security in your DevOps. That's called as a static analysis stage, wherein you are going to use a tool called as PMD. So the PMD is a plugin provided by Maven that will check your code for programming mistakes, static mistakes. Okay, so I will actually call it as yeah, that's fine. So the command is steps. As such, using the shell, you are going to run the command mvn pmd::pm. PMD here stands for Programming Mistake Detect. PMD::PMD is a command that is used to run the PMD plugin of Maven, which runs your source code to check for programming mistakes like unnecessary parentheses, out of memory error, connections have been created but not closed, using of certain you're recalling the loop again and again. Loop is going into infinite flow, or you have defined a condition but you have never called the condition. So such programming analysis are done by a Maven plugin called as PM. Okay, so I'm then going to build this stage. Let me build one more stage. After this, after we have completed static analysis, I'm going to add one more stage, which is my unit testing stage. This is the stage where my developer has given me some set of test cases. I want Jenkins to use Maven so as to pick up these test cases. There are some JUnit test cases given to us. So we want to pick up these JUnit test cases and execute them. Now, as you know, how you may be having a doubt that Sonar, from where are you getting the test cases? See, the first stage, we have already cloned the entire repository. So Jenkins is already holding the source code as well as the test cases. So you just need to tell Jenkins, hey, Jenkins, execute the following steps. What are the steps? Use the shell to execute the Maven command mvn test. So Maven has a plugin called a Surefire plugin. Using the Surefire plugin, which can be triggered using a command called as mvn test, you are going to execute the test cases which are available in the test folder and give the output as how many tests have passed or failed. So let me save this one and build the job. So if you see, we have cloned the repository. We are now compiling the files again. We are doing the static analysis. Any issues are there on the code, programming mistakes, we're going to find that out and then do the test cases also. Each of these stages will generate a report with you how many unit test cases have passed or failed. It's going to generate the report telling the programming mistakes done by the developer. Let me show you the reports. You can go to the build and you can scroll down, go to workspaces. In the workspace, if you go and check the target folder, you will have Surefire report, which is your target test report. Here the report tells how many test cases have been executed, how many have passed, how many have failed. It gives the complete information. and the time taken to execute the test case. There are 3 reports generated by the Shopify reporting plugin. They're all generated in XML. You can use the JUnit plugin of Jenkins to convert it into a trend report. If you will join the DevOps training, we will show you how to convert these XML files into the trend reports also. And here is a PMD XML file generated where you can see the programming mistakes done by developer. Like in line number 18, there is an empty catch block. Line number 62, there is useless parenthesis. There is a unnecessary modifier in line number 24. So this report is automatically generated by the Maven plugin. Jenkins is just triggering it. Maven is actually executing those commands on the source code. Let me build my pipeline, the last stage of the continuous integration in my pipeline I'm going to build. The pipeline that I've built so far, that is version controlling the code, compiling the code, analyzing the code, testing the code, and finally packaging it. This pipeline is called as continuous integration pipeline. Package stage. In this stage, I'm going to write the steps. Now I'm going to use a shell to execute the Maven command mvn package. mvn package. So package is a command which will take the source code and convert it into an artifact. Convert it into an artifact. What is an artifact? Artifact is an executable. Artifact is an executable which when executed or which when deployed on a server will allow the users to access the application. Okay, so when if suppose to understand executable, suppose you go to your browser and I ask you to download Skype. So when you download Skype, there is an exe file which gets downloaded in your laptop. That exe file is called as an executable, which when double clicked and pressed next, install the software on your server. Same thing I'm going to do, take the test case, take the entire code and package it into an executable so that I can deploy it on my servers. So let me save this and build the pipeline now again. So you will see the last stage here, packaging. So here we go, friends. Our first continuous integration pipeline is automated. But you may be thinking that I am executing the code again and again manually. How is it called as a one-click philosophy here? Jenkins supports a one-click philosophy. That means when you just give one click, all the stages should get executed one after the other. Even if you want to automate this click, you can do that by using the triggers here. There is an option called as build periodically. Let's say every 15 minutes I want to run this pipeline. So I can give a schedule here by using a cron tab format. This is the cron tab format that you have to use. Like how many minutes, what for every 15 minutes, or what time do you want to run? Which hour of the day do you want to run it? Which day of the month do you want to run it? Which day of the week do you want to run this particular code for, right? So this gives you, you can even set a schedule. Let's say I want to run it star means every minute at, let's say at 9 p.m. So we have already crossed 9 p.m. So let's say I want to run it at 22. Okay, at 10 p.m. is when I want to run my pipeline again, and I set a schedule here. Star here represents every day, every month, every day of the week. That's a schedule given. Suppose some more examples are given to you by Jenkins here, that let's say you want to run your job every 15 minutes. So let us take this cron tab. This tab here represents, so this is the Linux cron tab. Same thing. Every 10 minutes of the first half an hour. Once every 2 hours. Once every 2 hours slot between 8 a.m. to 4 p.m. You can give this schedule like this. So let me give a 15 minutes tab here so that we can see. Okay, so as per the schedule, the job will run in the next 15 minutes. Suppose you don't want the scheduled one. There is also an option called as poll SCM. Poll SCM is a process in Jenkins where Jenkins is going to check with Git. Has the developer done any changes on the repository? Let us say the developer created a file here and did changes to it. As you commit the changes, as a developer commits the changes here, immediately the pipeline will run. So let's do this. So let us do this. So I'm going to set again here. You have to give a schedule to Jenkins. Jenkins, at what time should it check with GitHub for changes? So let's say every minute. So I'll give star space star space star space star. Every minute I want Jenkins to check with GitHub if developer has done a commit. So always in continuous integration, that's the flow. Hold on, I think there was an error. Okay, there's no error. So do you really mean that every minute you want to run it? Yes. Okay, but observe the pipeline will not run. Observe the pipeline will not run until and unless the change happens on GitHub. The continuous flow says, if we are here, let me see if there is. The continuous flow says, so we have completed till here only, till here. The continuous flow says, as you version control your code or as the developer pushes the code in GitHub, your build pipeline, that is compiling the code, unit testing the code, package the code, should trigger automatically. So the setup is done in the following way. Now let's assume I am a developer of this repository. I will make small change in one of the files. Let me make a small change to a file. So let's say checkout on get. Okay. On the repository, if there is a commit, I'm doing a particular commit. On the repository, if there is a commit, immediately the pipeline should trigger. So give it a second. If you see here, there is a polling log created by Jenkins. So when every minute it is going to poll GitHub. If there is a change, it's going to trigger the job. Right now, note it did not poll yet. 343 it is going to poll. Since we did a change in the GitHub repository, it should trigger the job. Just give it a second. Yeah. See here, changes have been found. Since some changes have been found, automatically the pipeline has been triggered. If you observe, all your steps will be triggered again, friends. All the pipeline is getting executed again. Who is triggering the pipeline? Jenkins is triggering. Who is executing the stages? Maven is executing it. Where is the code available? In GitHub. So we have integrated 3 DevOps tools: Git, Maven, Jenkins. Right? Okay. Now, after this, we want to deploy the code on a particular server, friends. So next step is deployment. Deploying your code on the next server, on any other server. Now, deployment of the code can be done using a deployment tool. Now, there are 2 ways to deploy your code. Either you deploy the code in the legacy way, that is installing the Tomcat server or Apache server, placing the code on the directory and then restarting the server. You can do that flow, or you can do it with the help of containers, friends. I'll show you both the ways. Let me show you with containers, friends. Let me show you with containers. Containerization is the new latest way of deploying your application, friends. Okay, what are containers? Let us also talk about it before I build the pipeline. Friends, for deploying your code, we have the package available. Address book.war file. A package is available, a war file is available with. I need to deploy it on the next server in a QA environment or the staging environment in the form of container. Now, container is nothing but a package It's an environment. You can assume it to be like an environment which has its own network, which has its own state, which has its own memory, and your application that is running. So I want to place this address book war file. So I want a container which has Tomcat on it. Upon that, I want to place this address book war file. I want to place this address book war. Upon this, I want to also execute a command to restart Tomcat, right? And I want to expose this container. I want to access this container from the browser of my machine. So I'm exposing it to the port 88. So a container is nothing but it contains each and everything that is needed for your application to run. Right? Now, how do we create a container? That's again that's an important thing that you need to learn. So if you join the DevOps training course, we are covering Docker as a tool which provides containers. But to create container, no, you never create container. You launch a container. Okay, you never directly create a container. Never. So basically, there are three items that are needed for you to create a container. You always create a file, or you take, for that matter, any containerization tool like Docker, Rocket, CRI-O, Containerd, Linux containers. Any containerization tool, Docker being the market leader. So we all always think container means it is Docker. No, it is not that. Okay, so there are many other tools and all of them mostly follow the same process. What they do is they create a file, manifest file, or a file which is called, as in case of Docker, called as a Docker file. In the Docker file, any administrator who has to deploy the code will write the instructions, okay, needed to deploy the application. Needed to deploy the application. Okay, and then friends, after that you are this Docker file. So here in the Docker file, you provide a simple instructions as to what you need to deploy your application, to run your application. You provide this Docker file, and this Docker file is built into an image. Docker file or a manifest file is always built into an image. Image is nothing but, if I have to define, a static file which is a set of libraries and binaries for your application. It's a static file. It just holds the binaries that are needed for your application. Now this image, when you run an image, is when a container is created automatically. You never create a container. You always create a Docker file, build the Docker file. You build the Docker file and then run the image. Build the Docker file into an image, run the image. That's when the container is available for. It is available and is in running condition. As a user, from your browser, you access this container. From the browser, as a user, you will access this container and your application will be available to it. The running instance of an application is called as a container. The static instance of your application is called an image. What should be an image is on your Docker file. So let us quickly write a Docker file with help of Jenkins front. So let me show you. Okay. So what are we going to do is now, let us go to Jenkins and create a job. So let me continue the same pipeline. You can very well create another job also if you want, but let me write down here itself, deploy. So after this stage, now I'm going to write the next stage, which is going to be my deployment stage. Now for deployment, my steps are following. Okay, and before deployment, I need to connect to my server and install Docker on my system. We need to create containers, right? So let me quickly connect to my AWS machine and install Docker on. Let it connect. You also need to start Docker. Docker is a service that needs to be started. That is one thing. The next thing that you have to do is you have to go to a file called as vim etc sudo ers file, where you need to provide Jenkins. Okay, already there is permission. You need to provide Jenkins user full permissions to execute any command. Okay, any Docker command or any command on this server. Right, I've already provided Jenkins as a full user permissions. Okay, now let's go back here and start creating the steps for deployment. So your deployment could be on a QA server, deployment could be on a staging environment, deployment could be on production. Same steps can be followed. Okay, so I'm going to write a shell script here, and I'm going to say label, comma, script. Okay, so let's start writing the script here. My script is going to be, I'm going to start creating a directory, mkdir. Okay, so on my Jenkins server, wherever this stage is created, I want to create a directory called as my deployment, okay, or my app, anything. After that, I want to go into the directory, and after that, I want to copy the file. Now we want to copy the address book war file, the war file which is generated, into this directory first. So let me save it and go to the stage, package stage, where you can see the war file. So please go here, go to the workspace. In the not to the workspace, go to the console output which was last run. At the end of it, you will get the location where your war file is present. So this is the location where my war file is. Go to your pipeline and mention here, copy at this location, this war file in the current directory. After this, I'm going to create something called as Docker file. Docker file, and I'm going to ask Linux to run this Docker file until it meets end of text. Read Docker file. Read Docker file until you meet end of text. Now let's write down the Docker file. Docker file is nothing but a set of instructions that you want, instructions about the application and the softwares that you want on your container. So from is the base of your container. Like I want Tomcat on my container. After that, I want to add whatever is this address book war file. I want to add it. I'm taking Tomcat version 9. I want to add it to the Tomcat's root directory, which is user share Tomcat web apps. Okay, in this directory. After that, I also want to expose my container to the port 8080. Every container will be exposed to one particular port, French. It will be so that you can access the container from the browser of your machine. So it's mandatory that your container, if it is of web application, it should be exposed to a port 8080. Okay, and I'm going to run a command to start Tomcat. The command is, now you don't have to write all this, friends. You can very well go to hub.docker.com and search for the Tomcat image. Over there, it is, everything is available. So this is the Tomcat image. If you want to deploy an application on a Tomcat server, so if you scroll down, you can get complete information here. To start the Tomcat server, here is the command. To deploy on Tomcat, here are the to create a Tomcat container, to remove a Tomcat container. They have not given anything, but however, here is the home directory of Tomcat, and this is the command to start Tomcat server. Same thing I am mentioning here, start Tomcat server. Okay. Once I start the Tomcat server, I stop my Docker file here. That's all. So this is a set of instructions that I'm passing to Docker to take this Docker file and build it into an image. Now, so the Docker command to build the Docker file into an image is sudo docker build, okay, -t, build the Docker file into an image. So let's give an image name, my app version 1. I'm giving the name dot, okay, sudo docker, run this image now, run the image in a detached mode. That means keep creating my container, let it run in the background and do a port mapping. Now, if you join the Docker session, that's when we can explain you the topics of port mapping, what is detached mode, right? Port mapping, to tell you, is when the container is created, there should be a port number using which you can access it. So that port number you will get from this option called as port mapping. Give the image a name, my app version 1. Okay, that's all, friends. Let me close the script. Right, so I've started a script here and it went on to create this. So these are the steps that I've executed. Closing the stage. Stage is closed. Stages are closed. Why there is an error? Steps are closed. 1, 2, 3, 4. Let me save it. Yeah, there is no more error. Okay. So these are the steps to deploy your code as a container. So let me save it and let me run it. So my Jenkins and Docker are on the same server RP. If they are in different servers, then you have to use SSH to connect Jenkins to Docker. Currently on my same server, I have Jenkins and I have Docker. So it does not need to connect to any other machine. But in real time, of course, you will have another server where you would want to deploy it. So you need to create an agent on Jenkins. You need to create an agent on Jenkins that will that the master will connect to it and deploy it as a Docker container on the third server. Okay, so I think it has created the container for us. Let us first go and see if it has created an image. So in the DevOps training, we do execute those pipelines using Ansible playbooks also. You can deploy your code using Ansible playbooks and Docker containers. Okay, so let me see. Systemctl start Docker. Docker images, your image should be available. See my image. No, my image did not get created, friends. I think is it in progress? Please see here. So here my Docker file has been built. No, it did not. It did not build it. There's a warning here. Let me finish this. So I have the Docker file with me. Let me just quickly finish it. And how to use CI/CD for QA testing. So after the package, after you have deployed Mohammed, so after the deployment is done in the QA environment, the container of your application will be available. Then push your Selenium test cases into GitHub. Those test cases which are written by the testing team. Now create a next job here called as system testing, or create a job like integration testing, and ask Selenium. Clone the Selenium test cases repository and use Jenkins to run it, Selenium test cases. And you can also create a job in Jenkins to run the JMeter test cases for performance testing. Yes, Ansible playbook is not an alternative to Docker. Ansible playbook it will trigger the execution of Docker containers. Now, however, my deployment has failed. Let us go and check it. Cannot create the directory, file already exists. So directory is already available. That is why it is failing. Let us go and quickly make changes to it. That is okay. So basically Ansible is again a similar automation server where you write a playbook to install Docker, to start Docker, to create Docker file, to build a Docker file into an image and run it into a container. So Ansible can trigger everything for you on hundreds of servers. So here it is now creating the image. Can we integrate test cases report to the some test case management tool as well as with Jenkins job? You can. So test case reports like your HTML reports, your TestNG reports, your JMeter reports, your extent reports, you can. Okay. And see here, one image has been created and one container also got created. See, your image has been created and your container also got created. You can go and check it here. Docker ps-a. So here one container is just up and running on the port 49153. So if I take the public IP address of my server and go to 49153/address book. So here we have successfully deployed the application. Oops. Okay. Let me just see. Okay. All right, friends. And now I know the reason why it is not deployed. We need to make a quick change. I'm going to build now again quickly on those 100 servers. Now I think we should be through with the. So I have a container 49154. So here you go, friends. We have successfully deployed our address book application. I have started from the scratch, build the code, that is compile the code, unit tested the code, package the code, and deployed it into a container.
So continuous integration is like a software development lifecycle. Now, how does it work? So as you can see here, this pipeline is a logical demonstration of how a software will move along various phases or stages in this life cycle before it is delivered to the customer or before it is live. So just imagine you're going to build a website which is going to be deployed on the live web servers, and your product is a website or a web app. Now, you will have a set of developers who are responsible for writing the code which will further go and build the web app or website. So once the team of developers write this code and commit the code into the version control system like Git or SVN, it goes to this build phase. So this is the first phase of the pipeline where developers put in their code and code goes into the version control system having proper version tags. So you know which build has what kind of version tag. So any commit that happens and you find an error, you can just go to that particular version and then check the commit. So after you have your version control system phase done, then it goes to a build phase where you compile the code. So you get all the various features of that code from various branches of repositories. Then you merge them and then finally you have some compiler to compile it, and that is nothing but the build phase. So in build phase, what's happening is the code has been taken from the version control system and then it is compiled. So you know the code of all the features are merged and then it is compiled together. Once the build phase is done, you move on to the testing phase. So in testing phase, we have various kinds of testing depending on the type of the company or depending on the type of the product that the company is delivering. So one of the tests in the testing phase is unit tests. So what happens in unit tests is that you break your complete software into small little chunks. That is, the complete software is divided into chunks based on different parts. So every part has a code. So it is divided into small individual units to understand how it works, and when the test is completed, you have an assurance that that particular part is working. And once each and every part is tested, there is one more test that has to be performed, that is the integration testing. So what happens with integration testing is Now all these individually tested parts are integrated together and seen if they can work with each other or not. A software has many features where they have to work with each other. So that is tested in integration testing. After your testing phase is done, you next move on to the deploy phase, and this is the stage where you deploy your software onto the staging area or the test server where you're going to view the code. So in the deploy phase, the code is deployed successfully, and then you can run another set of sanity tests, and once you think that all the parts are working and everything is fine, you can finally think that it is acceptable, and then it is deployed onto the production stage, right? Meanwhile, in every step, if there's some error, development team fixes that particular bug and then pushes it into the version control system, which goes back to the complete pipeline again. So once again, if there is any error reported during testing, the feedback goes back to the dev team, they fix it, and that particular product goes to the complete pipeline again. That is, it again goes to the build phase, the testing phase, and then it is deployed onto the prod servers. So this is how in every phase, it moves on throughout the life cycle unless we get a code or a product which can be deployed into the production server, and there we can measure and validate that code. So pipeline is a logical step or a series of steps which define how software development lifecycle occurs. So guys, this was all about CI/CD pipeline. So now that you know a brief about all the stages in the CI/CD pipeline, let me tell you what exactly is continuous integration. So let's consider a scenario of a team which has 5 developers building a website which has many features. So let's say if this website to be a shopping website, right? So as we all know that in a shopping website, we have many pages like, the user details, the past orders, the shopping carts, whatever product a person has added to his cart, and so on. And then finally, we also have the checkout page and so on, right? So all these different pages are known as features of the software. So when you have multiple features, you have to combine those features and merge them into a single version control system, where you merge the various feature branches of the code and make a single pool of the code which can be now comprising of all the features of various branches committed by the developers, and then you can build it as a product and move on to the testing phase. So what are you basically doing? You're combining all the feature branches, that is all the feature codes, into a single branch, and once you combine it successfully, so you're then moving it to the testing phase. Now, when you merge the code and you build the code to get a single unit of the software, this is nothing but integration. So, integrating means putting all the code together from all the contributing developers and then merging the code and building it as a whole. Now, you must be wondering, why do we call it as continuous integration? The reason is because everything happens in DevOps continuously. So everything is automatic. So as soon as the person commits the code in the version control system, it continuously starts merging the process, and then it continuously starts also building the process simultaneously. So that is the reason that it is known as continuous integration, as nobody has to wait for anything. After the stage of continuous integration, we have continuous delivery. So as and when we move on to the various stages in pipeline, we finally deliver the product, because as soon as it passes the test and new features become functional, it can be used as the final area for the product. So everything happens in a continuous way. So the product is built, the product is tested, the product is then deployed onto the prod servers. So since it is continuously integrated, built, tested, and deployed and delivered, this process in short is known as the CI/CD process. Now once you have the continuous integration and continuous delivery in place, the deployable unit path is called pipeline. Now what do I mean by deployable unit path? I mean the path to the production servers where it is deployed onto the live servers. So now that you've understood what CI/CD pipeline is, let me show you a real life use case of a company known as Capital One. So Capital One is one of the well-known brands in America and is among the top 10 largest banks in the nation by deposits. It offers a wide range of financial products and services to commercial clients, small businesses, and individual consumers, both online and inline at branch locations. The company was founded on the vision that the power of IT and testing could be harnessed to bring the highly customized financial products directly to the customers. Now, the initial challenge was to increase the automation while ensuring stability, scalability, and security. As continuous integration practices were becoming increasingly mainstream, Capital One formed a continuous delivery tools team as a part of restructuring their company's technical organization. So this team was created to support thousands of developers by providing a solid service that helps them deliver software applications more quickly and in a more agile fashion. From a platform perspective, the technical makeup had to be extremely flexible to meet a wide variety of use cases, but it also had to be both stable and scalable. Further, as financial services company, Capital One needed its platform to be secure itself and promote improved security for the applications built with it. So, with these objectives in mind, the new shared continuous delivery tools team sought to implement the CI/CD practices that supported security practices without stifling developer innovation with reference to speed and security. So, the solution they found out was to establish a platform for CI/CD to deliver quality software with shorter time to market. So, how did they do that? So the shared continuous delivery tools team established an internal platform for automating builds, testing, and deployments based on cloud-based Jenkins platform. They used the role-based access control plugin to implement an authorization strategy in which security roles were assigned to a group of users. After the initial platform rollout, the team made incremental refinements over the time to improve operational efficiency. They decoupled their Jenkins agents from masters, giving them the ability to scale masters and agents independently using the Amazon Web Services. The team began using cloud-based Jenkins Operations Center to manage multiple masters and reduce the administrative time by ensuring plugin compliance and version consistency with the update centers. So the team settled on a single default environment for all the groups. On the top of the infrastructure created by the team, a common implementation pipeline layer was also created. So this is how they used the CI/CD pipeline, to solve their challenges. So after implementing the CI/CD pipeline, they saw that 90% of the pipeline was automated. So this increased the deployment frequency with 1300%. So that's a huge number, isn't it? So with the Jenkins platform, they created a service for the developers that was scalable and stable. As a result of this, the time that developers would have spent managing the infrastructure was now spent by developing business applications. And obviously, as I said, this increased the deployment frequency by year on year, right? And also, it was seen that the quality and the security of all the repeatable processes was ensured. So they implemented consistent repeatable processes in an automated fashion every time a developer wanted to commit or every time a developer wanted to deploy something. So this produced a more secure software, enabling them to deliver it faster. So guys, that was the use case about Capital One. So it was really clear to you, right, how they faced their challenges, they solved the problems with the help of CI/CD, and they could clearly see evident results. So in between the discussion, you must have also observed that I was mentioning Jenkins platform, right? So why do you think that they just used Jenkins? Why not anything else? So why do you think that Capital One went for Jenkins platform? Why was it so important to them? So let's understand what Jenkins is and let's understand the importance of Jenkins. So Jenkins is an open source automation tool written in Java with plugins built for continuous integration purpose. Now consider that you have to automate the entire process, that is from the time the development team gives the code to the time that code is deployed onto the production servers. So that there are various steps in the pipeline and you have to automate this pipeline. So how will you do it? So in order to make the entire software development lifecycle on the DevOps mode or the automated mode, we would need automation tools. So Jenkins is a really good automation tool that you can use. Now how is Jenkins going to help us? So let's know. So Jenkins provides us various interfaces and tools in order to automate the entire process. By entire process, I mean the process of the complete development lifecycle. So what happens is that, so suppose you have a Git repository where the development team commits the code and then Jenkins takes over from there. So Jenkins will pull that code and then it will move it to the commit phase where the code is committed to every branch. Then Jenkins moves it and then it goes to the build phase where it will compile the code. Now after the code is compiled and after the code is validated and reviewed, the code is tested, and once all the tests are done, it is finally packaged into an application. It could be either a WAR file or a jar file. So what Jenkins does is it is going to pull your code from your version control system, and then it is going to perform the build. It is going to compile your code. It's going to validate your code. It's going to again review the complete code. After that is done, it will perform the unit testing and the integration testing, and then finally it will package your application into a WAR file or a jar file, and then it is ready to be delivered. So that's what Jenkins helps us to do. So now you must have understood that this is the tool for basic continuous integration. But as I just said, Jenkins' role is only till the application is packaged. Now, if it has to be delivered, then we need some tools to deliver that product, right? So once the product or the software moves on to the staging server, to deploy it, we need tools like Docker. Now, what is Docker? So Docker is like a virtualization environment which we can create on the fly. So it just takes few seconds to create an entire server and deploy something on it. So to deploy some software, we will need an environment which will replicate the production environment, and that's what Docker provides. So Docker is not exactly a virtual machine, but it can create images like a virtual machine, and then it can run as a container which will completely replicate a particular platform or an environment where you can deploy your artifacts or jar files or any other kinds of files, and then you can test those files. So now that you know a lot of theory about CI/CD pipeline and you know the tools for CI/CD pipeline, that is Jenkins and Docker, let me show you practically how a CI/CD pipeline is created and how it is executed, right? So let's get started with our hands-on. So we're going to build a CI/CD pipeline using Jenkins and Docker. So for that, let me just open my VirtualBox Manager where I've installed Jenkins in my system. If you want to know how to install Jenkins, then you can refer to our video of Jenkins installation. Let's go to my VirtualBox. Before I start creating my pipeline, let me run the Jenkins service and Docker, right? So let me open the terminal. Let me enable the Jenkins service and the Docker service before creating the pipeline. So let me type in the command. So for that, I'll type in systemctl start Jenkins. So it will ask me my authentication. So I'll type in my password. And then I'll type in systemctl enable Jenkins. So as you can see that I've not got the privileges because I've not entered the command as the super user. So if you wish to enter the command as the super user, you have to type in sudo before the command. So you'll type in sudo systemctl enable Jenkins. And then you'll be asked for the password. So let me type in my password. And then you can see that your Jenkins server has been enabled. Now we also want Docker to run. So for that, we'll type in systemctl start Docker. Again, it's asking my authentication. So I'll type in my password. And then Docker has started. So our Jenkins service and Docker has been started. So now let's open our Jenkins dashboard. So for that, I'll open my local host. So let me open my Jenkins dashboard. So when you open your Jenkins dashboard, Jenkins always asks for the user ID and the password. Mention your user ID and the password and click on login. Alright, so this is your Jenkins dashboard. Now what I'm going to do is, I'm going to create a pipeline. So for that, I'll be using 3 jobs. The first job would be to build the project. The second job would be to test the project. And the third job would be to finally deploy the project. So for that, we'll be creating 3 jobs. So let me show you how to create new jobs. So for that, you have to go to new item. You have to type in the job names. So let me put in the job name as job 1 and choose as freestyle project and then click on OK. Once this is done, I'll again go back to my dashboard and create 2 more jobs similarly, that is job 2 and job 3. So let me type in the name job 2 and choose it as freestyle project and click on OK. And when it comes to the configuration part, I'll tell you what you have to configure soon. And then similarly, I'll create a new job, that is job 3. So let's go back to our dashboard. So you can see that 3 jobs have been created. Now I want to create a pipeline. So what I'll be doing for this pipeline is I'll be pulling a code from a Git repository, and that code is a Java web code which is basically given to the development team for the testing. So that is job 2 here. And once the testing is done, it will be deployed. So for that, you have to mention the repository's URL in your job to pull that code. So let's mention the repository's URL. So for that, I'll go to job 1, I'll go to configure, and then I'll go to the source code management tab. I'll go to Git because I'm going to mention the repository URL of a GitHub account. So I'll mention the repository's URL. So this repository has all the files related to the project. So this is where from Jenkins will pull the code and then it will perform the build, test and deploy operations in a CI/CD pipeline. So I'll click on this and save and apply. Similarly, I'm going to do it for the other two jobs also. So we have mentioned our Git repository for all the three jobs. Now we have to configure our jobs in such a way that when it performs the build option, it knows what code it has to compile and what all has to be installed respectively. So after mentioning your GitHub repository URLs for all the three jobs, our first step is to build the source code to get a WAR file, that is an executable file. Now what does this mean? Basically, when the Jenkins server pulls the code from the Git repository, it uses Maven to install that package. So for that, we have to mention the command of Maven install, and then Maven install installs all the dependencies that are required to compile this application. And once the application passes all the tests successfully, it will then use Docker to deploy it. So this is the process of the CI/CD pipeline that we're going to use. So for that, let's go to our job 1 and then configure it first. So let me open my job 1, go to the configure option, go to the build option here, go to add build step, choose execute shell because we're going to execute the shell commands, and then I'll mention the required commands. So the required commands would be here to mention the directory of our web code and then also mention Maven install. So because we want to install all the dependencies required to compile our project. So let me mention the commands. So as you can see that I've mentioned the required commands. So our first command is to change the directory of our web code. That is the directory in which we want the code to work in. And then we are using the command Maven install to install all the dependencies required to compile the code. After that, we want it to move on to the testing phase so that the testing is performed. So we're going to change the directory to the testing phase, and then we will verify the testing results with the help of this command. So this is what you have to mention in job 1. After you've mentioned this, you can then save this job 1. After that, let's configure job 2. Job 2 is where we want the testing to be done, and then we want it to be copied to the Docker file so that our application is deployed onto the prod servers. So for that, I'll go again onto the option of configure, and then I'll go to the build option. I'll go to add build step. I'll choose execute shell, and then I'll mention the required code. So after our job 1 has been built and tested, we want our application to be deployed onto the prod servers. So for that, we'll build a Docker container. So to do that, you'll use the commands to change the directory as cd java web code, and then to build a Docker container, you will use the command docker build -t DevOps pipeline demo. So that is the name I've given. You can give any other name that you want. After that, you can click on save and apply. Once this is done, let's configure job 3. That is our final stage where everything is tested, and then we just want it to be deployed onto the prod servers. But before that is done, we have to check one thing, and that is if our image has been created previously or not. If there is an image that is previously created, then we have to remove that old files. Else, if it is not created, then we can say that a new image has been created. Or if you say that there is no container existing at all, then you can reply a message that there is no container existing, right? So for that, let me just go to the build option again, go to add build step, go to execute shell, and then I'll mention the commands. Alright, so I've mentioned the required commands. So my container that I've previously created on job 2, that is DevOps pipeline demo, is running. And then over here, I'll check if it is previously existing or not. If it is existing, then I'll remove the files by using the command rm. And if it is not, then I'll print a message saying that the container does not exist. So that's how you can make sure that your container is previously existing or not. After you're done with this, you can just save and apply. So now that I've told you that we are creating a pipeline, that means all the jobs must be interconnected. So the pipeline should know after job 1 is built, what has to be built next. And after job 2 is built, what has to be built next. So to do that, we have to mention in the configure options of jobs. So let's go to the first job, that is job 1. Go to the configure option. And over here, I'll go to the post build actions tab. And over here, I'll choose build other projects. So I'll mention the next job that has to be built after job 1. That is job 2, right? So I'll mention job 2 and then I'll save and apply. After this is done, I'll go back to my Jenkins dashboard and I'll go to job 2 over here. I'll then configure job 2 and then I'll mention after job 2 is built, what has to be built, that is job 3. So I'll again go to the post build actions, go to the build other projects option, and then I'll mention job 3 here. So we have mentioned our post build actions. So now what will happen is once job 1 has been successfully built, it will automatically start building job 2, and once that is done, it will automatically start building job 3. So that's how you can build various jobs one after the other. So as I said that we're going to create a pipeline. So to create a pipeline, you have to go to this plus option here. You have to mention your view name. So that is your pipeline's name. So suppose I mention it as DevOps pipeline. So let me mention the name. And then I'll click on build pipeline view. And then I'll click on OK. Now once this is done, as I said, a pipeline should know from where it should start. So we're going to mention job 1. So that is where our pipeline will start. So I'll go to the pipeline flow section and then I'll mention the initial job as job 1. So that is already mentioned here, and once that is done, I'll click on apply and then click on OK. So that means our pipeline has been built. Now, if you have to run this pipeline, you just have to go to this option and run. So you can see that if the job 1 is in yellow, that means it has started running, and job 2 and job 3 are in the sequence. So as you can see that job 1 has been successfully built. So let me open my console output and show you. So you can see that our Git repository has been pulled. So the code has been compiled. All the Maven dependencies are installed that are required for compiling the application. And finally, we can see that our test results have been successful. In the second job, we were creating a Docker container. So let it run. So let me show you how the Docker container was created. Alright, so you can see that our job 2 has also successfully built. So you can see that all the artifacts have been copied and the Docker container has been created. So our job 2 was also successful in building. So let's wait for the job 3, and once it builds, I'll show you that it has been deployed successfully. Alright, so you can see that our job 3 has been successfully built. So that means that our CI/CD pipeline was successful. So before I move on to show you the output, let me show you the console output of job 3. And you can see that yes, our container did not exist previously and a new container was created, right? So guys, that's how you build the CI/CD pipeline. Now let me show you the results. So I'll go to my local host. So you can see that our application is running fine. So guys, that's how you can build a project and then compile the code by installing the required dependencies. And once that is done, you can push it to the test phase where the product is tested, and once it passes all the tests, it is then deployed using the Docker image, and once that is also successful, it is deployed onto the production that you can see in front of your screen.
Have you ever wondered why companies like Netflix or Amazon delivered updates so fast without breaking things? So, why is everyone talking about DevOps as must-have career in tech? Let's find out. First is the high demand, where it is a rapid adoption of cloud technologies and digital transformation initiatives have created a significant demand for DevOps professionals. Then is the lucrative salaries. DevOps engineers command competitive salaries due to their specialized skills and the value they bring to organizations. Next is a continuous learning. The DevOps landscape is constantly evolving, offering opportunities to continuous learning and also skill development. We also have career growth, where DevOps roles offer diverse career paths, including cloud architect, site reliability engineer, and DevOps consultant. The last we have is the impactful work. DevOps engineers play a vital role in success of organizations by enabling faster and more reliable software delivery. As technology continues to advance, DevOps will remain a critical discipline. By staying updates with latest trends and mastering the necessary tools and skills, you can carve a successful career in this dynamic field. Before diving deeper, let's quickly understand what DevOps is and why it's so critical today. DevOps is a combination of development and operations practices aimed at automating and integrating the processes between software development and IT teams. It enables organizations to build, test, and release software faster and more reliably. The importance of DevOps lies in its ability to enhance collaboration, where it breaks silos between teams, fostering better communication and teamwork. Then is the accelerate delivery. Speeds up the software release cycle with continuous integration and continuous deployment. We also have the improved quality. It also ensures faster bug detection and resolution through automated testing. Next is the boost scalability, where it enables businesses to handle growing demands with robust infrastructure automation. Last is the ensure reliability. It delivers stable and secure systems with real-time monitoring and incident management. In a world where speed and quality is everything, DevOps transform businesses, making them more agile and competitive. Now let's make this real with an example you can relate to. You're part of a team building a new app. Developers finish writing the code, but now the operation team faces roadblocks deploying it because of miscommunication, manual processes, or infrastructure issues. Do you know what it results to? Delays, frustration, and dissatisfied users. So, that is where DevOps steps in as a game changer here. Think of it as a cultural and technical revolution that connects teams, that is, developers and operations collaborate seamlessly, breaking down barriers. Then, which automates workflows, where tasks like testing, deployment, and scaling happens faster with less effort. Then, it also builds confidence. Every release is more stable and reliable because of automated checks and constant monitoring. Last is it drives innovation. By focusing on speed and quality, businesses can experiment, iterate, and also deliver better products to customers. It's not just a methodology, it's a secret sauce for delivering value quickly and also continuously in today's fast-paced tech world. In short, DevOps isn't just a buzzword, it's how smart teams win. Now that we know what DevOps is, let's talk about the skyrocketing demand for DevOps professionals in the industry. The content highlights successful DevOps implementation across several prominent organizations, emphasizing how adopting DevOps practices has transformed their software delivery, enhanced collaboration, and also boosted overall efficiency. In the case studies from Amazon Web Services, Capital One, GitHub, Slack, and the UK Government Digital Service showcase the power of DevOps in real-world applications. Common themes across these organizations include transitioning to microservices architecture, automating processes, fostering cross-functional teams, and leveraging cloud infrastructure. These practices enable faster development cycles, improved operational stability, and allow teams to deliver high-quality services continuously. The key takeaways include the importance of automation, continuous monitoring, and cross-team collaboration. By integrating these DevOps principles, organizations can streamline workflows, scale efficiently, and also respond rapidly to market demands, setting themselves up for sustained success in an increasingly fast-paced technological landscape. Are you curious about what it takes to succeed in DevOps? Let's explore the essential skills you need to master. The technical skills needed are: first is the programming, basics of Python, Bash, or Go. Then comes the OS and networking, that is operating systems, where having knowledge of Linux fundamentals, networking protocols, DNS, and firewalls. Next is the CI/CD, like Jenkins, GitLab CI, or GitHub Actions. Next is the IAC, tools like Terraform and Ansible. Then we have the cloud computing, like AWS, Azure, or Google Cloud. Have knowledge of containers and orchestrations, like Docker and Kubernetes. The last technical skill is the monitoring and logging, like Prometheus, Grafana, ELK stack. The soft skills that needed are collaboration with teams, problem-solving mindset, and ability to automate repetitive tasks. Once you have built the right skills, what does your career path in DevOps look like? Let me walk you through it. A DevOps career path is typically involves several stages, each building on technical skills, hands-on experience, and deep understanding of both development and operations. Here is an overview of the typical DevOps career progression. We have 3 levels. The first level is the entry level, then is the intermediate level, and the last is the senior level. In the entry level, we have roles like DevOps engineer, junior DevOps engineer. And in the intermediate level, we have DevOps specialist and DevOps analyst. Last, in the senior level, we have DevOps architect and then the DevOps lead. Now let's see the salary prospects of DevOps engineer. The average annual salary in India for the entry level is 3 to 5 lakh per year. And in the mid-level, it is 8 to 14 lakh per year. And moving on to the senior level, it is 18 to 30 lakh per year. Similarly, let's see the average annual salary in US for the DevOps engineer. For the entry level, it is $66,000 per year. For the mid-level, it is $100,000 per year. And lastly, for the senior level, it is $166,000 per year. Starting out can feel overwhelming. But don't worry, I've got some practical tips to help you kick off your journey. Building a strong foundation in DevOps. Let me take you through a step-by-step guide. First, start with the basics. In basics, we have first is version control, where master Git, the industry standard for version control. Learn basic commands like git init, git clone, git add, git commit, and even git push and pull. Next we have is the command line. Become proficient in using the command line, especially in Linux or macOS environments. This will be crucial for working with DevOps tools. The next step we have is dive into DevOps tools. In that we have first is choose a CI/CD tool. Start with the popular tools like Jenkins, GitLab CI/CD or 𝐂𝐐𝐿. Learn how to create pipelines, automate builds, test and deployments. Then is learn containerization. Understand Docker and Kubernetes, practice building Docker images and deploying them to Kubernetes clusters. Next is explore configuration management. Learn a tool like Ansible, Puppet or Chef to automate infrastructure provisioning and configuration. Last is the cloud platforms. Gain hands-on experience with cloud platforms like AWS, Azure or GCP. Learn how to provision and manage resources using their APIs or CLI tools. The next step is build a strong portfolio. Under that, we have first is personal projects. Create small DevOps projects to showcase your skills. Then, open source contributions. Contribute to open source projects to gain real-world experience and learn from others. Last is a GitHub profile. Maintain an active GitHub profile with well-documented projects and contributions. Here we have the next step, that is continuous learning. Under that, the first is the online courses. Learn from the online courses platforms which offer a wide range of DevOps courses. Next, we have tutorials and documentations. Refer to official documentations and tutorials for tools you're learning. Last is DevOps communities. Join online communities like Reddit, Stack Overflow, or DevOps forums to connect with other professionals and learn from their experiences. The last we have the certification. The DevOps certification adds a credibility tag to your skills, making a job search very important. It means higher salary and career growth, with the added advantage of being updated at all times on the current tools and best practices. Certification does not stand as only way, but it gives a huge advantage in the job market. You can also check out our Edureka's course DevOps Engineer Masters program that will give you a proficient in DevOps principles like CI/CD, continuous monitoring and continuous delivery using tools like Puppet, Chef, Docker, Git and Jenkins. It includes training on Linux, Python, Docker, AWS DevOps, DevOps Engineer Certification Training Course curriculum created by extensive research on 5,000 plus job descriptions across the globe to make you a certified DevOps expert. Remember, the key to success in DevOps is continuous learning and practice. Stay updated with the latest trends and technologies, and always be curious to explore new tools and techniques. Let's look ahead. What does the future of DevOps hold? And why should you jump on this exciting career path now? The future of DevOps in 2024 and beyond is set to evolve with the following key trends. First is the increased automation. DevOps will automate more complex tasks like testing, security checks, and system monitoring. This will streamline processes, reduce human error, and also speed up the software delivery pipeline. Then is the AI and ML integration. Artificial intelligence and machine learning will help DevOps teams by providing predictive analysis and also automated issue detection. AI-driven tools will optimize deployments and provide insights that lead to more efficient operations. Then we have the shift-left testing. Testing will continue to move earlier in the development lifecycle, ensuring bugs are caught early. This reduces risks and also accelerates release cycles by embedding continuous testing into CI/CD pipelines. Next, we have the DevSecOps. Security will be integrated at every stage of the development cycle, from planning to deployment. Using DevSecOps, this approach automates security checks and ensures that software is both fast and secure, addressing the growing need for secure software development. Next, we have the cloud-native and serverless architectures. The use of cloud-native technologies and serverless computing will grow. These approaches reduce infrastructure management, allowing teams to focus on code development and also faster deployments without worrying about underlying infrastructure. Then we have cross-functional teams. Collaboration will be further emphasized, with cross-functional teams like development, operations, and security working together to deliver software quickly. Breaking down silos between the departments will lead to faster decision-making and improved outcomes. Next is self-healing systems. Systems will evolve to be more resilient with self-healing capabilities. These systems will automatically detect and resolve issues, reducing downtime and to the need of manual intervention. Next we have the edge computing. With the rise of edge computing, DevOps will adapt to manage distributed systems at the edge. This enables faster data processing and improve performance for applications that need to run closer to end users. Then we have the enhanced monitoring and observability. As systems become more complex, advanced monitoring tools will be essential. Real-time observability will help DevOps teams track system performance, security, and the user experience, enabling faster issue resolution. The last is the talent and skills development. As the demand for DevOps continues to grow, there will be a significant need for skilled professionals. The role of the DevOps engineer will evolve to require expertise in automation, security, and cloud technologies and AI, driving organizations to invest in training and also development. Now that you have a clear roadmap to becoming a DevOps engineer, let's wrap things up with some final thoughts to help you take the first step confidently. In conclusion, the path of becoming a successful DevOps engineer is a dynamic journey that combines technical expertise, automation, and also cross-functional collaboration. As the demand for DevOps professionals continues to grow, driven by the rapid adoption of cloud technologies and digital transformation, the career offers not only lucrative opportunities but also continuous learning and career advancements. Key concepts like CI/CD, cloud computing, containerization, and DevSecOps form the foundation of the DevOps engineer skill set. Following a structured roadmap, starting with learning the basics and advancing to hands-on practice with tools and certifications, will prepare you for diverse career paths in this field, from the junior engineer to DevOps architect. Looking ahead, DevOps will continue to evolve with trends like AI and ML integration, self-healing systems, and edge computing, ensuring that DevOps engineer will remain at the forefront of technological innovation. To succeed, DevOps professional must embrace continuous learning, gain practical experience, and stay updated on the latest tools and trends shaping the industry. By mastering the necessary tools and skills, aspiring DevOps engineer can build a fulfilling and impactful career in one of the most exciting fields in tech.
And with this, we have come to an end to this session on DevOps for beginners. If you enjoyed listening to this video, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.